Then we look at high-level language translators. Now, I didn't go into detail up to this point, so let's see. This high-level language translators, there are two types of translators available for high-level language. So they are, one is called compiler. When I say compiler, it's a translator, remember, okay? Then the other is called interpreter, again translator. Why are we having compiler and interpreter? These are two different ways of translating, okay? That is why we have compiler does the translation in a certain way, interpreter does the translation in a certain way. So let's see how these two work, okay? So I think if you show a image or something like that, a graphical representation of this, it will be much easier to understand. So let's go to that, okay? So let's look at compiler and interpreter and see how they differ. Now let's say processor A is there, processor B is there, and this high-level language test is there. So we, as you know, processor A also won't understand high-level language test. Processor B also won't understand because these are not machine language now. So it can't directly go. So obviously we have the command in there. We need a translator, right? Now I want to show the two different types of translations, compiler translation and interpreter translation. So what I have done is I have used here the compiler translator, and here I use the interpreter translator to show how those two work, okay? So now the high-level language is there, and display 4+5 goes to the compiler in this case. In this case, it goes to the interpreter, okay? This is the translator. Okay, in this translator is called compiler, this translator is called interpreter, but they will do the same job. So let's see. So they translate. Now this compiler will translate to the add 4 and 5. The add is the process, this processor's add. Okay, this interpreter also will translate the add to this processor's add and 4 and 5. Add 4 and 5. Add 4 and 5. On this processor, add 4 and 5 on this processor. Okay, this translation is done. So now let's say where it differs. Okay, now this, since display is there, the display component also comes in for both. Okay, the interpreter translates these things as well as the display component. Compiler also translates these things as well as the display component. Okay, same thing. Now compiler, like what we saw earlier, writes into a secondary file storage plus with the instruction to display. This is what we have seen in our previous slides. I didn't use the word compiler, but those examples are compiler examples, okay? And most popular one out of these two is the compiler. So that's why I use the compiler example. So in the compiler, what happens is it takes these instructions, all the sets one by one. I am showing only one instruction, but if there are several, it take one by one all of that and write it into a file in the secondary storage. Okay, once it is written, you don't need this because you can run from here. So you take from here and run it to that, give it to the processor. The interpreter, as you can see, this step is not there. It directly gives the translation to the processor. Okay, it does not write a secondary file. It directly gives to the processor and this, okay, and the display part. All of this comes to the processor. For processor A, it comes from the file. For processor B, it comes directly from the interpreter. That is the difference between a compiler. A compiler will always compile it and write it into a file in the secondary storage. Interpreter will directly give it to the processor. And then after that, it's the same thing. 4+5 in both cases, so it's 9. Display 9, display 9. And then since the display command also goes, it will be shown on the screen. Okay, let me explain it in another way. Just think this is a person who can talk in English. Okay, he will only understand English. Okay, let's say he will understand English. He will understand English. Okay, no problem. Both are going to talk in English. Let's assume. Okay. This processor here we will say understands French only. This one also understands French only. So both of these understand only English. Both of these understand only French. So when they want to talk to the French person, they have to have a translator. Okay. So if the first let's look at how the compiler translator does. So he will talk to the translator person is here, okay, to translate English to French. Translator person is here to translate English to French. This compiler translator, what he will do is he will take a piece of paper, listen to what he has to say, and write it down on a piece of paper, all the things that he is saying in French. He will write everything down in French. After that, processor can take from there and do any number of times. It's in a piece of paper, so no issue. 2 days after even, processor can look at this and do that, same thing. So the translator won't be required after that. Once he writes a translation on a piece of paper, after that the piece of paper can be used and it's already translated in the piece of paper. So that is the way compiler works. The interpreter, what happens is, he will listen, the interpreter person, he will listen to the English words given by this, and every word he is giving, he will translate and tell the processor or the person who is here, French person. In French, he will say, okay, this is what it is. Then he will tell the second word, he will interpret that and tell that. Then and there, then and there, then and there, then and there, finish. Okay, let's say, okay, next day he wants to listen to the same thing again. He doesn't have any place to look at. He needs a translator to come again, and he needs this person to be there again. Okay, again he will tell what it is, and he will take each one and tell him, okay, this. Third day, every time this has to happen, the interpreter has to be available, and the high-level language also has to be available. Then only high-level language can tell the interpreter can translate and give it to the person who wants to understand French, and he will understand. So this is the main difference between a compiler and an interpreter. Compiler, you compile and put it into a file and keep it. You can take the file and keep on working with that, and you don't need this. In the interpreter, you need them all the time you want to do that, because he has to say that, he has to translate it and tell him. You have to say it, translate and tell him. He is not writing in a piece of paper, this one. This one is writing in a piece of paper. So just think of that. That is how a compiler and interpreter work. Both are doing translation, but how they are doing the translation is the difference between these two. Okay, in a compiler environment, the high-level language as well as the interpreter has to be there for the processor to do that. In the compiler environment, high-level language and compiler has to be there only first time to do the translation and write into the secondary file. Once that is done, after that only the processor will take from here and do. Processor will not take from here and do. Okay, he won't take directly from there. He will always take from here and keep on doing. So he can now do any number of times, and tomorrow, day after other day, he doesn't need this because it's already written in a file. He can take this file and execute and get the job done. Here, can't. Okay, they have to be there. Every time it has to be done. Okay, so this is just to give you some idea about how the compiler and interpreter works. Both are high-level language translators. Okay, right. Let's just now see a summary of all these types of translators. Machine language, and let's say there is a processor. Assembly language, processor. These two, machine language or high-level language, is called low-level language, and they are machine dependent. Whatever that they have to give has to be there. Okay, he can't give instruction to this. He won't understand. This instruction has to directly go to this one who understands that. So they are therefore machine dependent. Okay, whatever you give from here, the machine has to understand. Right. Then we take two high-level languages for the compiler and interpreter. So this is one high-level language, this is another high-level language, and the processors relevant to that. These two are high-level language, and they are machine independent, as we have seen. Whatever instruction that goes from here, this need not understand because the translator will do the necessary job. Okay, but in the assembly language, even though the translator is there, he is translating this language to these languages. Okay, he is not doing like the high level language. Okay, so whatever that is there here, that is exact thing in English is there. So the translator will directly convert that and put it here. So it won't work on another processor. Okay, right. So now machine language instruction, no need of translation, anything. It can directly take it. The processor can take it and run it. Assembly language can't, because this is in English like code. So you need the assembler, the translator. So the translator will take it first, convert it, write it into the machine language, and then the machine language can be now from the secondary storage taken into process and it can be executed. Okay. High level language is the interpreter. Again, you have to have interpreter because high level language won't be understood by the processor. So interpreter will take the instruction, directly tell the processor. That is how interpreter works, and then the processor can do that. So one high level language here will be several instructions going into the processor to do that particular high level language. Okay, here one instruction, assembler. That is the main difference between a high level language and low level language. In the next case, we are talking about the compiler. It's a translator. Again, instruction go to the compiler. It writes into a file the machine language version, and from there only the processor will do it. Okay, so this should give you some idea about how the high level languages, the different types of languages in the computing environment get translated to the processor. Okay, thank you very much. We will see you in the next video.